Okay, so if we're going to do number 17 here, we're just trying to find the exact length of the curve. So we want to do our derivative and then plug it into our formula. So derivative of natural log of something is 1 over that something, and then what do I still have to do? And then times by the derivative of that inside, it should be negative 2x, so I'm just going to write it as negative 2x over 1 minus x squared. So that's my derivative, and then the formula, I'll just jump back here. We have it with respect to x, so we're doing 1 plus that derivative squared, so I'm going to have to square that derivative and add 1 to it, and then throw it into that integral. So if I square that, the numerator is going to turn into what? Positive though, right? And the denominator, I'm just going to put parentheses around it and square it for now. Okay, so throwing that into my integral is going from 0 to a half, because it gives me that. And then I need a square root, right? And sometimes, like, if this is a multiple choice question, look at the answers to the multiple choice, because sometimes you don't have to go very far, because they actually just have, like, 1 plus this with squared, and you're done. So don't do all the work until you know you have to do it. So what I would probably do here is try to get a common denominator, because I'm not sure what else you would do necessarily. Let me see if that's where they went. Yep. So let's get a common denominator. If you want to leave the integral off of it and just do the 1 plus first, you could do that. Okay, so if I get a common denominator, it's going to be this here, right? So I'm going to have 1 minus x squared squared on top and bottom here, and then plus 4x squared. So I am going to FOIL the numerator part out. And should I FOIL the denominator part out? Does it make sense to FOIL the denominator out? No, because I'm going to end up square rooting it, so I want to keep it as that perfect square. The numerator, I want to combine this stuff together, which is why I'm going to multiply that out. So if I do the little scratch work here, 1 minus x squared times another 1 minus x squared, I'm getting 1 minus 2x squared plus x to the 4th. And then remember, I'm adding that to 4x squared, so I would get 1, well, let's put them in descending order. So x to the 4th plus 2x squared plus 1. So the only way I can see that that might factor, because we know we want this to be a perfect square if we're going to factor it and get it out of that square root. So we'd have x squared and x squared, and it'd have to be positive 1 and positive 1. Does that work? Yeah. So the numerator now is just turning into, yeah, 1 plus x squared over 1 minus x squared would work, because the squared parts will go away. Does that look okay? Now I feel like the denominator, I feel like this might be a partial fractions, because the denominator we got 1 plus x and 1 minus x. You see that? But what do we have to do if the degree in the numerator and denominator were the same? You had to do like your long division, right, to get that one piece out, because you can't really do it with that squared in the numerator. So that's what we would do next here. So I'm going to write this in descending order to do my long division. So negative x squared plus 0x plus 1 is going into positive x squared plus 0x plus 1. So what would I need to multiply that by? Negative 1. So then that turns into positive x squared. The 0x's are in both spots, so it doesn't matter. And then this is minus 1. And then when you subtract that, make sure you change the signs. So this goes away. This goes away, and this turns into what? 2. So then you have plus 2 over, and I'm just going to write that as the linear pieces, so 1 plus x and 1 minus x. You guys okay with that part? Okay, so now we've got that in the integral, so I'm going to do partial fractions to this stuff here. Okay, so I've got 2 over 1 plus x and 1 minus x. Good, so a over 1 plus x, and then b over 1 minus x. So then I'm going to multiply everything by 1 plus x and 1 minus x, so I just get 2 equals a times 1 minus x plus b times 1 plus x. That looks okay. And then we're going to use convenient values here. So a convenient value for x would be what? So let's just choose 1 first. So if I choose 1, I get 2 equals, and this is the part that goes away, and this turns into 2b, so b equals 1. And then we're going to let x equal negative 1. So I get 2 equals, and if I choose negative 1, I get 2a. That look right? So a is 1 also, right? Let me know if I messed something up. So we need to go back to putting that into this integral here. Now remember, don't forget about this minus 1 here. So we've got negative 1, and then plus, and we got 1 over 1 plus x. And then plus 1 over, and there's still one thing that a lot of people do wrong, and they do all this work, and then the multiple choice, they still get a question wrong that's, even though you did everything right up to this point. So when we do our integral here, the negative 1 is going to turn into what? Negative x. This part's going to turn into plus absolute value of 1 plus x, okay? And then this part here is minus, and it's minus because you have to think about the slope being negative 1, right? And you do 1 over the slope out front of it. So does that minus make sense there? Okay, then we still have to plug in from 0 to a half. So if I plug in a half, I get negative a half plus the natural log of 3 halves, I suppose it'd probably be written, but you can do 1.5 is fine. And then minus the natural log of a half. That look right? And then I'm going to subtract, and I'm going to plug in 0. So we get 0 plus natural log of 1 minus natural log of 1. So what happens to all this stuff? 0. So then this here, you just might have to clean it up so it looks like the answer in the back. So if I want to put logs together or natural logs together, when we're subtracting, that means I'm going to do what? Divide. So I have 3 halves, and I'm dividing by a half. Or you can multiply by 2, so what do I get actually then? 3. And I'm guessing that's what the back of the book has. They might have written it as natural log of 3 minus a half. Clear? Okay, number 19, I kind of glanced ahead at it here. I'm guessing what you're having trouble with is when you get to your integral, and you're just having trouble actually doing the integral without your calculator. We're actually going to do the integral of this without our calculator. So we're starting with our derivative. So our derivative, pull the 2 down, it goes away, and it's just x. And then we're going to do 1 plus the derivative squared, and that's what goes under our square root, right? So that's what's going to be in our integral. And what is our integral going from? Let me just double check that. So negative 1 to 1 for our x's. And then what the book does and what the AP test could possibly do here, What type of a function is this? Even or odd? Even. So if I plug negative x in, don't I get the same thing? So that means on both sides of the y-axis, if you plug a negative in, you get the same thing as when you plug the positive in on the right side. So it's an even function. So what the book does here, I see, is they're going from, they're doubling it and just going from 0 to 1. So this could very possibly be the answer, like on a multiple choice question. You would not have to do the integral of that by hand. So I would say from here you can finish with your calculator, but you should have gotten to that spot. Well, it says find, it does say for 19, it has that little calculator symbol. Find the length of the arc from P to Q. But like for the earlier ones even, find the exact length of the curve. So some of them you might have had trouble actually doing the integral. And there's some occasions where we just can't do the integral because it's not on the AP test, so we don't do it in class. Okay, so 23 says use Simpson's rule. We said we're going to use trapezoidal rule with n equals 10 to estimate the arc length of the curve. Compare your answer. So first thing we want to do is use our arc length formula. So our arc length formula, we're just going to be going from 0 to, I put 2x. What's it supposed to be? 2 pi. Okay, and then in here we're doing 1 plus, and we're going to throw a square root over it. And our derivative is, we're going to have to use a product rule. So first times the derivative of the second, plus the second times the derivative of the first. And what do I still have to do with what I've got here? Square it, this back piece. So if I square that, I'm going to do my work off to the side here. Well, and I suppose being we're using trapezoidal rule, do I really need to clean that up? You know, I'm thinking I'm going to do it by hand, but I'm not going to do it by hand, so I suppose I don't even need to clean that up. And then what you would do from here is you would put this square root whole thing in your calculator. And if we're going from 0 to 2 pi, what is my change in x? So how we can find that is you do b minus a over what? 10. So that's where I'm getting that pi over 5 that you said, right? So my change in x is pi over 5. So when I'm using my trapezoidal rule with 10 subintervals, you do change in x over what? 2. So you have pi over 5 over 2, which you could also write as what? Pi over 10. And where will I start when my function is what? 0. And then what do I have to do with all these middle ones? Multiply by 2. So I'm taking my function at where for the first one? Pi over 5. That's your change in x. And then you keep doing that. You're going to find your function then at another pi over 5 would be what? 2 pi over 5 and 3 pi over 5 and 4 pi over 5 and so on there. So plus dot, dot, dot. When we get towards the end, we've got 2 times something, and then the very last one, or not 2, yeah, 2 times f of something. And then the very last one, you're not going to multiply by 2. What should the very last one be? 2 pi. So the one before that should be what? This is how many pi's over 5? 9 pi over 5. Good. Okay, so you should do all those in between. So if we're doing 10 here, how many values should we have in here? 11, because you got your endpoints, okay? I'm not going to do the whole thing out because it's just calculator work. I think we did one in class there. Okay, and for 33 was the other one that was asked here. And that gives you the estimated arc length. Yep, it might not match the book exactly because the book talked about Simpson's rule and this is trapezoidal, but it should be semi-close. 33 says find the arc length function for the curve y equals 2x to the 3/2 with a starting point. So this is our p naught, our initial point at 1, 2. So if you remember this, what do I use for my second point then? like x comma y type of a thing, right? So when we're trying to find our arc length, we're going from what? 1 to x. And then once we evaluate this, we'll be able to plug anything in for that x and actually find that arc length really quick rather than calculating every single one. Okay, so in here we do our square root, and we do 1 plus, and we're going to do the derivative and then make sure you square it. So I'll just write it like this for now. So the derivative is going to be what? 3x to the half. So when I square that, I'm going to get 1 plus just 9x, right? Make sure I'm not doing something wrong there. And then how can I evaluate that integral? Okay, you can put it to the half, and then if you want to, you can do like a u substitution if that makes it easier for you. You can try it without and compare to a u substitution. If you're doing a u substitution, what would your u equal? 1 plus 9x, and I shouldn't use x's in here because I'm going x here, so those are t's. I just don't want you being confused later, like why are there too many x's, but so 1 plus 9t, and then our derivative of that would be what? 9 dt. So then you have to remember 1 over 9 out front. Remember how we can do it without a u substitution? You just remember 1 over slope out front. As long as that's a linear function, that would work. So I suppose I'll give you guys a couple minute head start on that. So if we actually evaluate that integral, then this is like a u to the 1/2. So it's going to turn into u to the what? 3/2. And then I have to multiply by what out front? 2/3. And instead of u, I'm just going to put that 1 plus 9t in there. And then what else do I have to remember if I'm treating this as like that linear function, 1 over the slope, right? And if you do the u substitution, you should get the exact same thing. So this would turn into 2 over 27, 1 plus 9t to the 3/2. And then you still have to evaluate that going from 1 to x. So let me just compare with the book before we move on. That all looks good. So then plug in x, you get 2 27ths. And then we've got 1 plus 9x to the 3/2 minus, and then we got 2 27ths. And this turns into what? 10 to the 3/2. And I suppose you can leave your answer like that. You pull a 2 27ths out, obviously. This isn't going to clean up super nice, but they might write it a different way. Yeah, so the book ends up with a 2 27ths pulled out front, and then they left the 1 plus 9x to the 3/2 because that doesn't really clean up. And then 10 to the 3/2 is a 10, square root of 10 is how they wrote it, same thing.